Hi everyone, this is the video that goes with chapter 6b, which is going to talk about variation a little bit more in depth. So why does variation even matter? So here's two different wait times for customers at two different banks. The first one is Big Bank, and you can see from this graph that the wait times for these people kind of are pretty spread out. You can wait anywhere from 4.1 minutes to 11 minutes. For Best Bank, on the other hand, it looks like we're waiting anywhere between 7 and 8 minutes when you round it off to the nearest minute. So Big Bank has very high variation. This is very spread out. And Best Bank has very low variation. This is not spread out at all. These times are all very, very close to one another. So why does it matter? Well, the research on this topic tells us this. Most organizations collect and report on metrics that are not descriptive of their processes. Most metrics that are reported are the average or the median. But here's the truth of the matter. Customers don't feel the average, they feel the variation. Customers don't judge on averages, they feel the variability in each transaction. Customers value consistent, predictable business processes that deliver world-class levels of quality. In other words, they feel the difference and not the average. What does that mean? That means, going back to this, that these people here are more likely to be unhappy because they don't know what they're getting involved in each time they go to the bank. They can have a really short wait or a really long wait. And just because you have a chance to be a 4-minute wait time doesn't necessarily guarantee that. The times are kind of all over the place, and human beings simply don't like that kind of change. For Best Bank, even though on average the people wait a couple minutes longer than the shortest wait here at Big Bank, consistently it is the same. So they know what to plan for. They know exactly what they're going to get every time, each and every time they go into Best Bank. And so that these people are more likely to be happier with their experience at Best Bank. How do we measure variation? So there's two main ways that we're going to talk about here. One of them is called the range. The range is the difference between the highest and the lowest data values. So you're literally just going to subtract the high minus the low value. Okay, so consider the following two sets of quiz scores for 9 students. Which set has the greater range and which set has the greater variation? So let's take a look. For quiz 1, we have the low score of 1 and the high score of 10. And for quiz 2, we have a low score of 2 and a high score of 10. So the range for quiz 1 is 9, and the range for quiz 2 is 8. You're going to subtract the high minus the low in each of these to get those answers. For the variation, on the other hand, quiz 1 had pretty much no variation at all except for that one outlier. But in quiz 2, all of the scores were different, so they were completely spread out. That's very, very high variation. So quiz 1 has the greater range, the lower variation, and quiz 2 has the lower range but the higher variation. The next topic is called a 5-number summary. The 5-number summary is used in statistics to create things called box plots, which is also a way of looking at variation. So the 5 numbers are this: the low value, the lower quartile, the median, the upper quartile, and the high value. So the lower quartile, which is also called the first, is the median of the lower half of the data set. The middle quartile, or the second quartile, is the median. And the upper quartile, which is also known as the third quartile, is the median of the upper half of your set. And then a box plot is drawn from these 5 numbers. So you have your low value, your lower quartile, your median, your upper quartile, and your high value, your maximum. So you put a line on each of these 5 numbers, and then you box in the middle 3 for the quartiles. So they want you to calculate the values for Big Bank's 5-number summary and then create a box plot. So here's how I start them. I find my low and my high values first because they're easier to find. So my minimum is 4.1, my maximum is 11. There's my first 2. Then from there, I cut this in half and find the median. The median is the one directly in the middle of the whole set. So there's my third number for my 5-number summary. Once I have the median, I can now see the lower half of my set and the upper half of my set. So the median, when you're doing the quartiles, the median is the divider. It does not get included in the calculation for the lower quartile or the upper quartile. Okay, so that means to calculate the lower quartile, I need to find the median of these 5 values, the 4.1, 5.2, 5.6, 6.2, and 6.7. Those are on my lower half. The middle of these 5 is 5.6. So there's my 4th number. And then I'm going to do the same to figure out the upper quartile. So remember, the median is the divider, so it's not included. So these 5 values are in the upper half. I need to find the middle of those. The middle of those 5 is the 8.5. Now I have all 5 values for my 5-number summary. From there, I'm going to put a line on my number line for each of these values. So I'll put a dash at 4.1, a little mark at 5.6, one at 7.2, one at 8.5, and one at 11. And then I box in the quartiles. So the lower, the median, and the upper, get a box put around them. So there's my box plot. And these pieces here that are extending out, those are called the whiskers. When you look at a box plot now, the further spread out this is, the higher the variation is. And now we're going to look at it with Best Bank, which we already know looking at the bar graph that this was very low variation. But now we're going to look at it in a different way with the box plot. So first, let's find the 5-number summary. I find my low value, then my high value, then my median. Then I look at the lower half of my data and find the median of that. Then I look at my upper half of my data and find the median of that. And there's all 5 numbers from my 5-number summary. Now from here, I'm going to mark off each number from my 5-number summary, box in the quartiles, and I can see, looking at this graph now, the whiskers are very, very close to the box. That means that there is not a lot of variation here. There are no outliers. Everything is very close and tight, and that means there's not a lot of variation. The last thing we're going to talk about is another way of calculating variation, which is called the standard deviation. This will also tell you in a different way how spread out your data is. It is calculated using this very complicated looking formula, but what we're going to do is we're going to go through it with a table and step by step so you understand how to get all of this information. So you take the square root of the sum of the deviations from the mean squared, which I'll explain on the next slide. Then divide that by the total number of data values minus 1. You take the 1 off anytime you're calculating standard deviation that's used with a sample, which is almost always what will be the case. It will be the case for all of the questions on your homework as well. You would not take off 1 if you were using the full population, however. So here are the steps. First, we need to find the mean of your data. This is the notation for that. This is called X bar, and it is notation for the mean. Then you find the deviation of each data item from that mean. So you're going to subtract each data minus the mean. And we're going to do this as a table to keep this all organized. Then whatever you get for this answer after you subtract, you're going to square it. This will turn those values positive if by any chance they were negative, because you can't have any negative values when you do the end part of the square root. So these are going to remove any negative values that you have. Then you're going to find the sum of them. So all of these answers that you got after you squared, you're going to add them up. Then you're going to count the number of data items that you have and subtract 1 from that. And then at the end, we can combine these two steps together with the calculators that we have. We're going to take the square root of all the sum answers and divide it by the n-1 value that we got. So this will probably make more sense when we go through an example. So let's take a look. So we're going to find the standard deviation for this set of data. Here's our 5 data items right here. And what I'm going to do to keep this all organized is I'm going to put them in a table, and then each step will go through one by one. So the first thing we're supposed to do is find the mean of our data. To find the mean, we have to add these up and divide by 5. I got a mean of 18. Next, we're going to subtract each value minus the mean. So it's going to be 16 minus 18, 17 minus 18, 18 minus 18, 19 minus 18, and 20 minus 18. It's whatever your data is minus the mean. And that gives us a value for each row. -2, -1, 0, 1, and 2. Third step, we're going to take each of these answers that we got and square. So we're going to do -2 squared, -1 squared, 0 squared, 1 squared, and 2 squared. And that's going to give us new values to work with. We got a 4, 1, 0, 1, and 4 again. The fourth step is to add up all the answers you got after you squared it. So 4 plus 1 plus 0 plus 1 plus 4. This notation means sum. So the sum of all of this was 10. The next step is to count your data items and take 1 off of it. So we had 5 data values. 1, 2, 3, 4, 5. There's 5 of them. I took 1 off. That's a 4. And that's where n-1 comes from. This 4 right here. Now at the end, I'm going to take the square root of 10 divided by 4. And that's going to give me an answer of 1.58. This is my final answer then. So that means that this data has a standard deviation of about 1.6. And the lower the standard deviation is to 0, the less spread out your data is. The higher your standard deviation is, the more spread out it is. So here's another set. First, we're going to put them in a table. And then we're going to calculate the standard deviation by first finding the mean. So I'm going to add up all of these and divide by 5 again. That gives me the mean of 39. Now I'm going to subtract each of these minus the mean. So 32 minus 39, 37 minus 39, 38 minus 39, 42 minus 39, and 46 minus 39. Next, I'm going to square each of these numbers. -7 squared, -2 squared, -1 squared, 3 squared, and 7 squared. Now I'm going to find the sum of all of these answers here. 49 plus 4 plus 1 plus 9 plus 49 is 112. So there's the sum of my deviation squared. Next, I'm going to divide that by n minus 1. Now, n is 5 again, because there's 1, 2, 3, 4, 5 values. So 5 minus 1 is 4. So when I go to plug in n minus 1, it's a 4 again. And I'm going to take the square root of 112 divided by 4. And that's going to give me 5.29. Since that standard deviation is a little bit higher than the last one, it just means that my data is a little bit more spread out than the last set is. To do this in Excel, all you need to do is enter your data into a blank workbook, create a table, and then in a separate cell, type this formula in. It starts with an equal sign to represent a formula. Then it's STDEV, standard deviation, dot S. That means for the sample. That's going to subtract the 1 for you. Within the parentheses, then you just select the range of data that you typed in. So whatever cells you typed your data in, it will go inside these parentheses, and then press enter, and it will do it all for you. So I'm going to show you how we're going to do that here. So an auto transmission manufacturer receives ball bearings from different suppliers. The ball bearings must have a specified diameter of 16.3 millimeters with a tolerance of plus or minus 0.1 millimeters. Recent shipments from one of the suppliers had the following measurements. So here they are. And what I'm going to do is I'm going to open up a separate window here with Excel and show you how you could type this in and how you could find the standard deviation and the mean without actually having to make those tables and do it by hand. Okay, so here I have a blank workbook opened up from Excel, and what I'm going to do is just type my data values in. So first I am going to type in the formula to calculate the mean, because they're asking for both. To find the mean, it's an equal sign first for any formula, then it's average. Even though we just talked about how average can represent a lot of different things, in Excel it's the word average. So you type the word average out, then it's parentheses, and then you select where your data is. So you need to tell Excel that my data is in cells A1 through A7. Then close the parentheses. And here's the mean. Okay, now let's do the standard deviation. So for standard deviation, it's equal sign, just like any other formula, and it's STDEV dot S because we're working with a sample. And then it's parentheses. It's going to be the same group of cells here because this is where our data is. A1 through A7 in this case. Close them, press enter. So here's your standard deviation for that. Okay, so for the second part of the question, we're going to take a look and see which ones actually meet the specs. So it says here it's got an answer tolerance of plus or minus 0.1 millimeters, and the 16.3 is the measuring point. That means that these ball bearings can be anywhere from 16.2 to 16.4 millimeters, and they would still meet the correct specs. So out of that, we need to find the values from this list that actually fall within that range. All of these are within the range of 16.2 to 16.4. 16.41 is the only one that's too big, and only by a little bit, but it falls outside the range. So to find the percent that is okay here, we have 1, 2, 3, 4, 5, 6 values that are okay out of 7 total. So I divided that and multiplied by 100, and that gave me about 86%, which meet the specs. Here's another example of the same thing, but now this is a different supplier, so they have different measurements now. So they want the mean and the standard deviation using Excel, and they want to know what percent of ball bearings from supplier B meet the specifications. So I did the same thing. I put the information into a blank workbook, and then I typed in the formulas for each of these for mean and standard deviation. And I got about 16.325 for the mean, and the standard deviation is about 0.098. Then, to figure out how many of these actually meet the specifications, it's the same range that they have to fall into. Only these 4 actually meet the specifications here. So 4 out of 7 in this case fall within the range, only 57% then. That means supplier B is sending you almost half of these that are not usable, and you should probably find another supplier. Okay, now there's one last thing to talk about. Instead of finding a precise standard deviation, you can also find an approximate standard deviation using the range rule of thumb. And what that means is you take the range and divide it by 4, and that'll give you an approximate value for your standard deviation if that's really all that you need. You can also estimate the low and the high values from your data if you know the mean and the standard deviation instead. It's the mean minus 2 times the standard deviation, and the high value is the mean plus 2 times the standard deviation. So here's an example. Studies of the gas mileage of a Prius under varying driving conditions show that it gets a mean of 45 miles per gallon with a standard deviation of 4 miles per gallon. Estimate the minimum and maximum gas mileage that you can expect under ordinary driving conditions then. So since we know the mean and the standard deviation, we can find the minimum and the max by plugging in the mean minus and the mean plus. So the mean minus 2 times 4 is 37, and the mean plus 45 plus 2 times 4 is 53. That means minimally you should expect 37 miles per gallon all the way up to 53 miles per gallon. And that wraps up the end of this section and the end of this chapter. You should now be able to complete homework 10 and the last quiz, quiz 5.